So this workshop is a 1-hour workshop. So I'm going to try to finish in 45 to 50 minutes, and then I will be open to questions. And again, good morning, good afternoon, or good evening, depends on where you are, which time zone you are in. Thank you so much for attending this workshop, and I'm going to share my screen right now. This workshop is about experimental method in hospitality and tourism. Let me share my screen. Just want to make sure is everybody able to see my screen right now, the PowerPoint? Thank you. Okay, for the sake of time, I'm going to go right into my presentation today. I'm going to, in this presentation, I'm going to talk about, let me see, okay, it doesn't, okay, how do I, right here, okay. So in this workshop, I'm going to talk about the foreign contents, the type of research, and what is an experiment, and also the experiment terms, type of experiment, how to design a good experiment, and some tips on the statistical test. And also I conducted a survey with over 100 editorial board members to learn how they review experimental papers. So I'm going to share some of the study results here as well. First of all, regarding the type of research, there are 3 types of research. First is descriptive research, which generates first-order knowledge. So it is mainly let's say you just give out a survey and do some descriptive statistics, kind of describes who your customers are or what your products is like. Those are really first order knowledge, and nowadays very, very few journals are publishing purely descriptive research. This is more like an industry white paper if you try to do this. And the second type is the majority of our publications, journal articles today. Now, they are looking at relationships between variables. So this is called correlational research, and it generates second order knowledge. So for example, you can look at the motivation of a tourist and then related to their satisfaction and intention to revisit. You conduct a cross-sectional survey, and then you got the data, you analyze the data using either regression or SEM. Those tells you the correlation between your variables, like independent variable, and dependent variable. And thus, it does provide some useful information to our field, because it explains that your independent variable, like motivation, is correlated with your dependent variable, for example, satisfaction or revisit intention. However, this type of research, correlational research, could not tell you about causal relations between the variables. So it does not really tell you whether the motivation causes their satisfaction or revisit intention. Since you are just conducting a cross-sectional survey, your data come back, only tells you correlation. It does not tell you the causal relationships. And then our last type of research is called causal research, which generates third-order knowledge, which our industry and academia highly value. This type of research the typical example are experiments. So in this type of research, the scholars will control or do some manipulation of the independent variable, and then they will measure the dependent variable to check the causal relationship between independent variable and dependent variable. Through causal research, you will be confident to say that your independent variable X is causing your dependent variable Y. The main con with this, or the main disadvantage of this type of research is it would be time consuming and expensive. Sometimes you won't get the results you are expecting as well. So let's get a little deeper into what a causal research look like. The causal research investigate cause and effect relationships. So the cause is something happens, so it would be your independent variable. You do some manipulation with that, and then you will measure the effect of the cause, the dependent variable. To further explain why I say that correlation is not causality, we look at a study was conducted in 19th century. So it's looking into a myth that stork deliver babies. So in 19th century, scholar Matthews, he conducted a research and looked at the number of storks and the number of newborn babies in a list of countries. And then he found a very significant positive relationship between the two numbers. The correlation is 0.62 and the p-value is less than 0.01, so which is very significant. So can we, from what he conducted from the statistics, can we comfortably say that storks deliver babies? No. Anyone who with a basic knowledge or with a normal brain won't say that, right? So why it happens? There is correlation, but we cannot say there's a causality that storks are the reasons why we get new babies. There's no causality there. So if we want to look at that, there's multiple ways can cause correlation. So we look at the X variable, our independent variable, and Y variable, that's our dependent variable. So when X is the cause of Y, there is correlation. But on the other hand, that when Y is the reason of X, that also causes correlation. So that's a lot of situation. That's many times when you have this situation in your cross-sectional survey that, oh, you have satisfaction, you have revisit intention, but who causes who? This is correlation, but it doesn't give you any causality. It might be satisfaction causes the revisit intention, or it might be revisit intention causes your satisfaction. So it could be either way. And in the correlational study, you usually propose your hypothesis based on literature. So you will say, oh, based on the theory, we propose that maybe X will possibly relate it to Y, but there's no causality. It's still correlation. And the third reason that would cause this significant correlation would be there is a third variable, Z, that causes both X and Y. So it makes X and Y has significant correlation, but there's no other causality in it. And that is what happens in this case, because they are looking at the number of storks and the number of newborn babies in different set of countries. So there's a third variable. The researchers think that's the land area of that country that causes this positive relationship and significant relationship. So they used the third variable Z, land area, and look at the correlation between the number of stalks and the land area, and the number of newborn babies and the land area, and then they found both significant correlations. They found significant correlations in both relationships. So it kind of, on the side, it kind of supports that, okay, there's a third reason, Z, that causes that X and Y has significant correlation, but that significant correlation does not tell us anything. There's no causality, nothing. So we cannot say, oh, if we want more babies, we should raise more stalks, right? There's no way we're gonna do that. Anyone with a normal brain won't do that. So it brings us to this causation rules. There are three basic fundamental rules for a causality to be established. First, there should be significant correlation, right? There should be an evidence of association between X and Y. So that's correlation, significant correlation. And then the second is the time order. So X must occur before Y. That tells us that it's X causes Y, not Y causes X. And that's a basic assumption in the experiment, that we need to do something to our survey participants to cause them to do something as response. So there has to be a manipulation in experiment that makes the time order, like our independent variable X, appears before Y. And the third rule is absence of competing causal explanations. So in the stalk and baby case, we have to say that there's no third variable Z exist. So this in experiment, later we will explain a little bit more, is to how we can control of other causing factors, other factors that may cause Y on top of, like besides the X, our manipulation variable, the variable of our interest. So that gets us to the definition of an experiment. An experiment is the study of cause and effect. It involves us as scholars to manipulate one variable, and we are also trying to keep all other variables constant. So that's controlling of other possible explanations. And then we're going to measure the effect of the variable. So that's our dependent variable Y. So this again summarizes our three different types of research and how we can tell which research is which type. So first we look at, is there a treatment? So that's our manipulation. So if there's a treatment of manipulation, then it will be the third level, the third order of knowledge, and that's part of experimental design. And we'll talk about randomization later as well. So there are three different types of experiments. In two of them, we can randomize our participants, how they are assigned to each cells or each conditions. But there's one type of experiment, we called it as quasi or natural experiment, that we cannot do this type of randomization, but we still consider it as one type of experiment because there is a treatment. So X has to occur before Y, your dependent variable. But if there's no treatment, then it would be either descriptive research or correlational research, and it looks at first order or second order knowledge. So to give you an example, a simple example, if we have a research question to test or prove this folk wisdom, eating cheese shortly before going to bed will give people nightmares. Then for non-experimental design, what you're going to do is you can do a large-scale survey. You just send all surveys to all households and ask them, two questions. One, do you eat cheese before you go into bed? And the second, do you have nightmares, right? So that's a non-experimental design. Why? Because there's no treatment. You're just sending out the survey to household and collecting data and then test that correlation. And again, even that you find a correlation between eating cheese and nightmares, the number of nightmares, it is still a correlation, not a causality, because there's no time orders. So for an experimental design, what you can do is you can recruit, let's say you can recruit 100 people, and 50 people, you ask them to eat cheese 15 minutes or 30 minutes before they go into bed. And then you will let them do it for a week, and then you will ask them each day how many nightmares they have or whether or not they have nightmares. For the other group, the other 50 people, you don't let them eat cheese for a week, and then you also do the same thing, collecting whether they have nightmares every day. And then at the end, you will do a chi-square or t-test, looking at whether the two group has any difference. Then you can say, okay, that eating cheese will lead to nightmares, because so that is a causal relationship, because we do give treatment this time. So the treatment, eating cheese, is given before they go into the bed and before they having the nightmares. So let's get into our experiment terms. First, in experiment, we have independent variable and dependent variable. That is the same as any quantitative research, right? But it is a little different here in experimental design, in that in experiment, the independent variable is the treatment or the manipulation the scholar gives to our participant. So it's not something you use a survey to measure. It's more like a manipulation, a treatment. You give it to your participants. And the dependent variable is the one that you measures. So according to literature, that there should not be any common method bias in experimental design, because you are not measuring your independent variable and the dependent variable at the same time. Again, remember that independent variable is the one you give to your participants as a treatment. So in our nightmare or cheese experiment, that our independent variable is eat cheese versus not eat cheese, right? We have two conditions, which we will talk in the next page. So that's our independent variable. So eat or not eat cheese. The dependent variable will be the number of nightmares, or whether you have nightmare or not in each night. So it's kind of like a repeated measure if you are doing it, if you are doing the same thing for a week. So it will be 7 dependent variables repeated measured. Experiment terms, other experiment terms like conditions. Conditions means different levels of independent variable. So in our cheese experiment, again, you have two conditions. Eat cheese is one condition, and not eating cheese is another condition. So you have two groups. And when we talk about randomization, that means you have to have your 100 participants randomly assigned to two groups. And ideally, you will have 50 people per group, but sometimes there's always people like quit during their your experiment, or they don't even complete your experiment. So you might see slightly different numbers in two groups, which is totally okay. So you have experimental condition, and in the cheese experiment would be eating cheese, and the control experiment would be not eating cheese. So one thing I want to point out here is you may have one or more experimental conditions, and you can also not have a control condition if it really depends on your research question. So like one of my study, I looked at whether virtual reality ad is better than a traditional video ad. So my focus is to compare the two conditions, and I don't care about the control condition, the people who do not receive the ad. Then I will have two experimental conditions and I don't have the control condition. So I assume that, okay, giving ad is better than not giving the ad based on the literature. So that way the experimental design has two conditions. Both of them are experimental conditions and there's no control conditions, which is totally fine. The next set of terms are controlling variables and confounding variables. So first, controlling variables is the one that you will try to hold them constant across the experimental conditions. So if we think about the cheese experiment, we want to try to make sure all our 100 people, they are sleeping in the same room on the same mattress, and all the outside like a noise or light, they are all the same for everyone. So try to control those variables that might cause nightmares besides the eating cheese or not, besides your independent variable. However, no experiment can control for everything, especially if you're conducting some field experiment. It's even harder. For lab experiment, it might be easier. You are asking your participant to come to your lab, and then to come to the lab, and the lab has a set environment and it's the same, it's constant for any participant. So that's probably easier to control your other variables. But for field experiment, it might be much harder because people are in a real environment, like in a restaurant or in a hotel. So the outside environment would change, depends on what time they go there, and depends on who's serving them, depends on who are the people surrounding them. It's very hard for researchers to control everything. So that comes to the next term, that confounding variables. So that confounding variables are uncontrolled variables that might cause your dependent variables change. So you would like to add the questions that you thought it might be something that, okay, I cannot control it, but I want to see if that causes my dependent variable. So for example, I did a lot of those restaurant studies. One typical confounding variable I would add in that study would be, are you hungry? So this is something I cannot control. Like, okay, people, I don't know when they come to answer my survey. I don't know whether they eat or not before that. So, but I think that whether they're hungry or not may causes their intention to purchase food, right? It's very, very straightforward relation, I think. And also, so usually I would add that question in my survey and use that as a control variable when I conduct that ANCOVA. So that way I throw that in to make sure when I excluding that variable, when I controlling for that hungry level, I'm still getting a relationship, significant relationship between my independent variable and dependent variable. The hypothesis and non-hypothesis. So in experiment, just like any other quantitative studies, you need to write hypothesis. So you need to propose the relationship between your independent variable and dependent variable. And many times we would have also mediator, moderator as other correlational studies. However, the writing of experimental hypothesis is different from other quantitative studies like correlational study research. So in a correlational study, you will say in a hypothesis, you would probably say your independent variable X is positively related to dependent variable Y, right? Or you can say, oh, my X is negatively related to dependent variable Y. However, in experiment, you do not write hypotheses like that. You would say there are difference or there's no difference between the two conditions. So let's say the cheese experiment. You would say the hypothesis would be eating cheese would cause more nightmares than not eating cheese. So you are proposing the difference. Or you can say there would be difference in number in terms of the number of nightmares between people who eat cheese and not eat cheese before they go into bed. So that would be the hypothesis. So you will not writing that like eating cheese is positively related to your nightmares. You want to emphasize that difference there. There are two different types of experimental hypothesis, directional or non-directional. For non-directional, you will say there's no difference. For example, you can say, oh, there's no difference in terms of people's visit intention, whether they watch a virtual reality ad and sorry, the non-directional would be you just to say the difference, but you don't say which one is better. So you would say, okay, there's difference in terms of people's visit intention, in terms of whether they watch a virtual reality ad or they watch a traditional ad. But for the directional, which is usually preferred nowadays by reviewer, you would say people who watch virtual reality ad would have a higher visit intention than people who watch traditional ad. And usually you will get those kind of direction based on the literature. You can say, okay, this condition is better than the other, or this condition is worse than the other. And you can propose this type of directional hypothesis. And that is preferred in experimental design. The manipulations is control over the independent variable. And there are two types of manipulations. First is environmental treatment. That's all we can call it, like a physical treatment. So the eating cheese and not eating cheese is a physical treatment, right? But there's another type which used more in today's, especially hospitality studies, that's instructional manipulations. So that means that you will give them some verbal instruction and let them to think. So like one example would be you could give them a paragraph, let them to read, and then you are talking about, oh, older people is doing everything like not as good as younger people. And then the other condition, you'll give them the same paragraph, but you are kind of flipping your description saying that, oh, older people is doing everything like a favorable than younger people. So you are kind of like changing, but what you are changing here is like the favorability of the older people. So like older people has more favorable their personalities and characteristics, but then in other conditions, you are saying, oh, younger people has better. So this way, you are kind of trying to manipulate their perception, your participants' perception, but not using anything like a physical. You are just, you give them an instruction, let them to read, and let them to think. So in this case, you have to use manipulation check because your variable is not a physical treatment and you are not sure whether people reading the same instruction as you are reading it. So you will have to give them some 1, 2, 3 questions as your manipulation check to make sure you are manipulating the right, your manipulation achieves the desirable result as you expect. So as I said before, there are 3 types of experiments: lab experiment, field experiment, and natural experiment. So lab experiment is, in the past, it means that you have to ask participants to come to a research lab and you give them some treatment inside the lab, so it controls all their outside environment, surrounding environment. So that is the best to get to let you to reach to the conclusion of X causes Y. So the internal validity would be the highest for lab experiment, because you know that you controls all surrounding environment, you controls all the possible variables that may cause the dependent variables. So everything is controlled. The only thing not controlled is your independent variable. That way, it's very easy to get to the conclusion that X causes Y. Nowadays, more and more paper or experiments are conducted online, and it is kind of similar to lab experiment, but it has less control than lab experiment. So we call it online laboratory, but it does not have as high internal validity as laboratory experiment, because you couldn't control the environment when and where your participant is taking the survey or experiment. The next level is field experiment. Just as I said, you can do it in a destination, you can do it in a restaurant, in a hotel. These are all field experiments. So in field experiment, you control less. However, your result is easier to be generalized into the real world. So it has higher external validity. The last type would be natural experiment, or we can call it Causal experiment. So an example I can give you here would be, let's say you have a certain policy that may help destination to grow their tourism better. So you have that policy, you only apply that policy in one destination, not the other. So you can pick these 2 destinations and check it back, maybe after the policy applies 5 or 10 years back, and then you look at their tourism numbers, and then you compare them, and you can say, oh, okay, so this policy is good because after 10 years, this destination applying this policy, their tourism industry has the number of tourists has grown, and the tourism income growed as well. So in this type of experiment, you cannot do randomization. Again, it's kind of like, it is a treatment, but you cannot do randomization like you do for any other type of, and like you do for the other 2 types of experiment, like laboratory or field experiment. So there's a trade-off, just as I said, when you have high internal validity, you have lower external validity, your result is harder to generalize. But when you have high external validity, when your result is you are conducting it in all natural environment, there will be so many confounding variables that might impact your results, the dependent variable. So the internal validity would be lower in that case. That is why in experimental design, usually we encourage multi-experiments. So you can do one lab experiment, then you can do another field experiment to test the results. That way it tries to balance the internal validity versus the external validity. And also you can use different scenario when you do multi-experiments. The experimental design you can do within, when it comes to the participant distribution, you can either do within subject or between subject. So for within subject, it means that all the participants will get both conditions. If you have 2 conditions, they will get both conditions. So for example, that cheese experiment, you can say, okay, I'm going to recruit only 50 people, but the first week they will eat cheese, the second week they're not eating cheese. And then I'm looking at the results of the nightmares all among the same people. The good thing about within subject experiment, it will excluding all those personal differences. Although we always saying that, okay, in between subject design, we do randomization, but still they are different people. So they have different characteristics. So within subject design, these are exactly same 50 people. So that way we have less confounding variables. Remember, confounding variable is a bad thing that it might cause the dependent variable to change. And it will make you to not get into the conclusion that X causes Y. So the only bad thing about the within subject design is it might have a carryover effect. So let's say we give all those 50 people cheats the first week and they have a lot of nightmares. That may cause them their sleeping quality in the next week also bad, right? So what happened in within subject design is you have to use a technique called counterbalancing. So that means you will, for the 50 people, they are also they're getting both treatment, but they are all still divided into two groups, randomized into two groups. For 25, they eat cheese the first week, not eating cheese next week. But for the other 25, they will not eat cheese the first week and eating cheese the second week. So you're trying to do this counterbalancing to try to exclude those carryover effects. Between subject design is used more in our field, really because many times we're using a survey design, and let's say I have 4 groups and the survey takes 10 minutes. So if you are doing a within subject design, that means they have to take the same survey 4 times. That will take them 40 minutes to complete the survey, which we really don't think we want our participant to do that, and it will really cause the survey fatigue. So the bad thing, the disadvantage of between subject design is it will have the individual differences that might be your confounding variables. So the technique we use to control this or try to reduce these individual differences effect is the randomization. So again, as I said before, because the within subject design has a lot of has really good advantage, you don't have to worry about those individual difference, which are really big issue. So the rule of thumb is try to see if you can use this within subject design first. If you can do the within subject design, great, because it also saves you money. You recruit less participants. But in many cases, if you're doing a long survey, that's hard for to do this within subject design because it will take really, really long time. So we have to do the between subject design. And the sample size, some rough rule of thumb is 30 participants per condition, but nowadays I don't think, especially if you're doing an online experimental design, when collecting data is not really a big issue, this number is way from effective. So the Cohen also have a reference on how many sample size is enough. And if you look at the 4 groups that for alpha equals 0.05 and a median power would be 45 people per condition. So that times 4 is 180 for an experiment, a 4 cell, 4 condition, 2 by 2 like. And then the third way, you can also use G power to test or find out the find out what is the minimum required sample size. For statistical testing, it really depends on what kind of variable your dependent variable is. If it's a numerical dependent variable and your independent variable is categorical, so that's usually t-test or ANOVA. But if your dependent variable is categorical, for example, if you ask that nightmares, you just ask them yes or no as nightmares, then it will be categorical, then you have to use the chi-square. And then if your independent variable and dependent variable are both numerical, then it's process. And that's usually used for mediation or moderation. So right here. The effect size, sometimes you will have the reviewers ask you to report the effect size. For t-test, you usually report the coherence D, and for ANOVA, you would report that partial eta-square, and both of them have that cutoff value according to Cohen 1988. The power is very important, and the more powerful, the smaller differences the experiment can detect. So what do we do to increase power is, first, you can increase the number of participants. So the more participants, the more power the experiment is, and the smaller differences you can detect. And also the within subject design can also be used to increase power. Then that's why within subject design is more preferred than within subject design. I don't have a lot of time to go over this. I think I have about 5-6 minutes left to go over this, and then I want to see if you have any questions. But we did conduct a survey with a list of editorial board members. We sent emails to 1,000 of them, and more than 100 of them answered our survey. And these are the list of journals we sent to, and these are our respondents. So the scholars, the average age is 50 years old, and their academic experience average is 19 years. So they are prestigious scholars in our field, and we want to know what they think about experimental design. So they mentioned some of the common problems they witnessed in the papers they reviewed with experimental design. So the highest one is lack of internal validity. So that means you do not control your variable or do some confounding or test the confounding variable very well. So that makes your independent variable and dependent variable, those the correlation or the causality does not, you cannot get into that conclusion, or you cannot confidently say that X causes Y because there's a list of confounding variable over there. Sampling issue is also one thing they mention a lot. And the external validity is, they also mentioned that, so that can be solved by multiple experiments. So if you conduct 3-4 experiments with different samples, with some different scenario design, that will help with your results generalize. Theoretical contribution is also one thing they mentioned, because they think that sometimes you are really doing experiment for the sake of experiment. No, you have to look at your research question and decide if an experiment design is the best for this research question. So when we look at their review criteria, first of all, the overall design, and as I said before, you have to really look at the research question and see if the research question is suitable for experimental design, and what are the theoretical contribution behind your experiment. So if you are just testing a very simple relationship everyone knows, then why? Like, why do we still need this research, right? Why do we still need this experiment? And the ensure causality, again, is how you can control your variables well, and how you adding correct, appropriate confounding variables in your research. Multi-experiment and mixed method are both something they are looking into, especially top journals. So one experiment with 2x2 design is not enough. It does not tell us anything. It might be just a coincidence. So you have to retest the scenario with different population, with some different scenario design, with definitely same independent variable and same dependent variable, but it's different scenario design to try to increase your external validity. So in terms of stimuli and manipulations, one very important thing they mentioned is the realistic scenario. So whether the scenario, because again, nowadays, many of us are doing online experiment. So the scenarios the participant receives, are they real, or do they feel like, okay, this is something I will have or I will see in my daily life? So this would be a big question they're looking at, a big criteria they value. In the third one underneath there, they talked about the realism check. So that's definitely something that you want to conduct in every experiment, especially when you are using an instructional manipulation. So you want to make sure that the participants, they think the scenario they met in the experiment are something they really think would happen in the real life. So for example, like, okay, you are giving them a manipulation of a car, you are selling a car and you are saying this car is only $1,000 or $2,000. That people will not think it's realistic. They don't think it's something they will met in the real life, and that way your results would be hardly generalized to real life. Or let's say you have like a hotel room and you are saying it's just a $10 or $5 a night. So that's just something you have to think about it. You have to think about, and when you design your scenario, try to mimic the real life scenario or something you will meet in the real life to make sure people think it's real. And manipulation check is also a very big thing. So you really have to do, usually in my studies, I always check my manipulation in a pretest and make sure that's something that works successfully before I conduct my main experiment. Because if the manipulation check does not pass, that means my results, the whole results is not valid, or it's kind of meaningless, because people are not even perceive there's difference between the independent variable, and so how would that difference independent variable matter? So you really have to make sure your manipulation check is passed and your manipulation works as well as you expect. In terms of data collection, you have to make sure first your sample is representative. And again, when I say multiple experiments, that would be really good. Like, okay, you can do a student sample, you can do a real customer sample, you can do samples in different countries like US, UK, and like Asian country, whatever. So that will make your sample more representative to the population, what you are looking into. And adequate sample size, which we mentioned before, so you can look at the references or you can use the G-power. But really, please remember that G-power gives you a very, very minimum sample size, and you really want to be well above that sample size. The online data quality is something they really questioning. So if you are doing multi-experiment, try to make like one online, one field, and etc. In terms of reporting, so they are saying that some studies are that missing that reliability check or validity check of your measures. And p-values, so some of them supporting 0.05, and some of them also said 0.1 is acceptable. That's based on some marketing journals. Data analyze method, so usually experiment does not use complicated data analysis method. So t-test, ANOVA, chi-square process would be it. So if you are getting into like SEM for experiment, it will be like a big question mark there. And report your effect size. that's what I just said before, Cohen's D or that partial added square. So both of them are effect size. And then you can say it's small, medium, large effect. And don't afraid about the small effect because we are social science. Again, social science does not have really high effect size. And at the end, I want to say this is one thing we found from our survey with this over 100 prestigious scholars in this field. They all think that in our field, we need quality experimental research. However, the papers they review, they feel like the manuscripts submitted lack rigorous experimental design. So we are really calling for quality experimental research. So don't get me wrong that, oh, editors don't like experiments, so I should not do it. We are looking for quality experimental submissions. However, you have to do it right because the experimental design is different from the correlational research. And that concludes my study. And any questions? You can, if you have any questions after the workshop, feel free to reach me at this email address, or this is my personal website. You can go to my personal website and check it out, check what publications I have or other stuff of me.
Hello.
Yes.
Yeah, my name is Kilian from Macau Institute for Tourism Studies. So currently, I also have the research about the experiments, but I'd like to ask, what's the difference between the quantitative research and qualitative research applied in the experiment?
Thank you, Kilian, for your question. Experiment design is a type of quantitative research. So I do not think it can be categorized as qualitative.
Okay, so because I also see some scholars, they use experimentals in the qualitative research.
I don't think it's correct. Qualitative is qualitative, and quantitative includes what I talked before today. So descriptive, correlational, and causal research, all these are type of quantitative research, and experiment should be one type of quantitative. And if you have any reference, feel free to send it to me, and I want to check how they do qualitative in experiments. But based on my knowledge, I believe experiment should be quantitative.
Okay, thank you.
Thank you. Thank you for your question. I also see a question in the chat. How to make good manipulation for online survey? So I would suggest you only make one difference between your conditions. So if you are designing some stimuli, just make one thing different, not making a lot of things different across the conditions. So that way, people might be easier to test. And also, sometimes I found out pictures would help on top of the words. That many times also helps the participants to perceive or figure out the difference between the two conditions. So you have the word that describes the difference, and you also have the pictures. However, if you are using two different pictures, then you have to always test collecting the confounding variable and ask if that picture is attractive, that adding that as your confounding variable in your data analysis. But many times I've found that a picture would help. People are very visual. Yes, the picture brings into that problem that there would be some confounding variable there. And also, I think it also depends on the data collection platform. I'm not a fan of MTurk. MTurk people, they don't read, they don't think, they just click. So nowadays, I never conduct experiment on MTurk. So I have tried to use exactly same manipulation on MTurk and on prolific. And MTurk never comes with a good satisfactory result to me. And prolific always come back with a really good results. I've tried to test like, okay, 2 pictures, one is old, one is young. So that's very obvious. And on MTurk, I will get that, okay, for the people who's old versus young, it's like a 5.5 versus 4 point something. But on MTurk, on prolific, I would get a result as 6 point something versus 1 point something. So on MTurk, people don't really think, they just click, and they like to click in the middle. So like they like to, if it's a 7-point scale, you always get 4, 5, 6. Oh no, actually 3, 4, 5, right? So it's always in the middle. And maybe like middle go toward to more agree. So it's like 4, 5. But on prolific, people really read and think that data quality is much better. So again, it really goes back to your data quality, like the platform you use. And in person, like a field experiment would be much better than online experiment. People like are behind the screen, they're just clicking and you don't know what they're thinking. Thank you for giving the name.
Hi, Dr. Leung. My name is Violet from University of Illinois. Thank you so much for your presentation. I have a question about sample issue in experimental design. So I have been doing several VR lab experiments. And because it's in-person data collection, it is likely to be a single source population. So I think, as far as I know, the journal editors don't like single source population papers. Actually, one of my papers was rejected because of that issue. So I'm wondering if you have any recommendation or suggestions for to handle this sample issue in experimental design.
Thank you, Violet, and also thank you for providing the name of prolific. So as I said before, I strongly recommend multi-experiments. So you want to do experiment twice or 3 times, so you make it and put that in one paper. So if you read the top marketing journals right now, like JMR, Journal of Marketing, JCR, some of them conduct over 10 studies in one manuscript. And I know it's not right now in the hospitality, we're not up to that standard yet, but I'm seeing more and more 2 experiments, 3 experiments, 4 experiments, one in one study. So that way you can do one with student and one is not student, then that way will help to improve especially your external validity of your findings. And yes, I agree that a VR experiment is pretty hard, and especially couldn't do it online. And before I did try to, in the lab, I have to get the students go out to the society and just recruit those travelers, general travelers on top of the students. But right now it's definitely getting harder and harder to publish with pure student example. I'm sorry if that disappoints you.
No problem. Thank you for your answer.
It's almost time for the end of this workshop. And any other questions, or we can end this meeting. Oh, I think I got another question. Okay, so Callian, your question is asking how to conduct a mixed method with experimental design. I think like before I did, it's not really mixed method because I did a quantitative. So I did like analyze those triggers and then collect like 1,000 triggers and analyze them and use that to feed into my stimuli design. So I find, okay, these two different type of triggers, and I use that to feed into my experimental design, and then conducted 2 experiments afterwards. For qualitative, you can do like interviews and you figure out, okay, these are the independent variable I want to look into in experiments. And then you add an experiment to test. But that's more toward into more mixed method design workshop. Maybe you can watch that. I have not conducted a lot of mixed method using experimental design. I did a lot of those multi experiments. So I hope that helps. But
Okay, thank you very much.
Thank you for your question. Yes. But I definitely believe that multi-method and mixed method is definitely a trend which helps increase your study results, external and internal validity. So with that being said, we are over 1 minute. So I'll let you go, and I hope you will enjoy our left of our symposium, and I hope you all have a great day or great night. Thank you so much for joining me.